All right, it's coming down to this. This is the review for the final exam. Your final exam will consist of 30 questions. You will have 2.5 hours to accomplish this. Once again, it is uninterrupted time, so whenever you start, you have 2.5 hours to finish. So don't start until you're ready to go and have nothing else in front of you. It will be available from Friday through Sunday, and that is Friday at 8 a.m. through Sunday at midnight, basically 11:59 p.m. So you have basically 3 full days, 2.5 full days to accomplish this, and 2.5 hours to do it. The 30 questions is what you're going to study. You're going to study the review. The reason you're going to study the review is because each of the 30 questions in the review is almost an identical twin to the 30 questions on your final exam. If those of you who went through the review for the first test, you notice that the problems on the test were very, that's 3 varies, very similar to the problems on the review. The same is going to be true here. You know these problems, you're going to know the problems on the final exam. All right, here we go. First of all, it says, solve the following linear equation. We're going to take these one at a time. If there's work I need to do additional, I'll do it on the blue, and I will provide both the problems themselves and the work for you on your blackboard. Quickly content. Obviously, the first thing you're going to do here is distribute. Let's do that. Negative times a negative plus. Hey, there's more W's over here, so I'm going to subtract 9W. Get W by itself, do the opposite, add 70, and I'm finished. So answer, W equals 49. Now pay close attention to how the question is asked. If it says something like this, obviously don't put W equals 49 in that blank, just put 49. Got the idea? So answer the question as it's asked. So that's number 1. Number 2. Solve the following formula for the indicated variable. I get C equals 2 pi r. I'm asked to solve this for r, i.e. get r by itself. It's multiplied by 2 pi, so I do the reverse or inverse operation of multiplication, which is division. I divide both sides by 2 pi, and I'm finished. R equals C over 2 pi. That look familiar? You've seen that before, I think. Okay, consider the following inequality. I got 2 steps on this one. So solve the inequality. Express in interval notation. So you may recall this. If not, this is a good time to remember. When you're solving an inequality, get your variables on the left. That way, when you speak the inequality, the variable will be the subject of your mathematical sentence. So minus 5z minus 5z. Hey, it works out nice anyway, but even if it made negative z's, get your variables on the left. Add 18, add 18. I get z is less than 3. Let me make sure I got the inequality symbol right. I do. All right. So it says solve the inequality and express in interval notation. So the solution is z is less than 3. But the way I express that in interval notation, and it's nice to have a graph before you do the interval. The graph is going to look like this. Anything less than 3, so it's all this stuff, less than 3. It doesn't have an equal to sign on it, so I will not use a bracket. I will use parentheses at 3 to show I'm not including the point 3. And the way that looks in interval notation is from negative infinity all the way to 3. And since 3 is not included, parentheses, I always use parentheses with with infinity symbols. Okay, not too bad there. Plot the points on the Cartesian coordinate plane, to which you're probably going to say, really? That's pretty easy. So all you got to do is find 7, 2, 5, 6, 7, 1, 2. Find negative 2, 1. Find negative 8, negative 9. Negative 8, negative 9. And 6, negative 9. 6, negative 9. So I'll plot all these points. That's the first part. That might be all of it. I don't know. Let's find out. Yep, that's it. That's it for number 4. Just plot some points. Number 5, consider the following equation. Find the x and the y intercepts, if possible. Now remember, this is called standard form. Y's, x's, and y's on one side, numbers on the other. And this is set up, this is wonderfully designed to find the x and the y intercept. Remember how to find an x-intercept. You let y equal to 0 and solve for x. So I'm going to let y equal 0. Some of you are doing it much more shorthand way than I'm doing it, but that's fine. This is 0. 0 minus 4x is minus 4x equals 8. Divide negative 4, x is negative 2. So I've got my x-intercept is the point negative 2, 0. And answer negative 2, 0. Now let's find the y-intercept. To find a y-intercept, I let x equal to 0 and solve for y. So in the place of x, I'm going to put 0. I get 4y equals 8. Divide by 4, y is 2. So there's my y-intercept, 0, 2. Notice the x-intercept has a value in the x position. The y-intercept has a value in the y position. All right, graph the line by plotting the x and y intercepts. So I'm going to find these points, negative 2, 0, and 0, positive 2. And that will allow Hawks to plot the line for you. Just put those 2 points, and it will plot the line for you. All right, so far so good. All All right, let's find the slope of the line determined by the following equation. 7y equals 12. All right, here's a little bit of info I'd like to give you, and you're going to have this handy when you work your test, so you can refer to it. Slope, that's SOLPs, slopes of lines. 3 types. A, only y's in the equation. That's just like this guy. There's only y's in this equation. Example, 7y equals 12. If I have only y's in my equation, I have a horizontal line, and its slope is 0. Now I know you're thinking, hey, it's just got y's in it, I bet it's parallel to the y-axis. No, if it just has y's in it, it's parallel to the x-axis. So just y's, horizontal line, slope is 0. So just like this, answer, slope is 0. Second occasion is only x's in the equation. Something like, oh, I don't know, 4x equals negative 30. Just x's in this equation. When that happens, I have a vertical line, and its slope of a vertical line is undefined. So you only got x's, undefined. Only got y's, 0. The more common is you have both x's and y's. Example, 4y equals 2x plus 16. And what that means is you're going to have to find the slope. Put it in slope-intercept form. That means solve for y, so I'm going to divide every part by 4. And the slope will become wonderfully visible. Right here, 2 over 4 is 1/2. So there's my slope. So if you have both x's and y's, put the thing in slope-intercept form, and the slope becomes obvious. All right? Just y's, 0. Just x's, undefined. All right, consider the following equation. This is number 7. Consider the following equation, expressed in slope-intercept form. Notice it's got x's and y's in it, so here we go. Little distributive, negative times a negative. Okay, now, if I'm putting it in slope-intercept form, the y's alone have to be on the left. So I'm going to add 10 to both sides. I get 5y is, I'm going to put the x's first because the x's go first in the slope-intercept form. And this is minus 2. Divide by 5 and I got it. Slope is 6/5 in case anyone was wondering. Y-intercept is negative 2/5. So this is what they want to see, slope-intercept form. Step 2, find the equation of the line which passes through the point, and they give you a point, and is parallel to the given line. So here's my given line. If it's parallel to it, that means the same slope. Parallel lines have the same slope. If it said perpendicular, I would want to take the reciprocal and change the sign, the negative reciprocal of the given line. So I'm going to express my answer in slope-intercept form. Here we go. Remember, y equals mx plus b has 1, 2, 3, 4 variables, and I have something to fill 3 of those variables. I have an x, I got a y, and I got a slope. Slope is 6/5. So I'm going to fill those 3 things in and find out what b has to be. All right, so this is a continuation of 7. So my y is 1. My slope is 6/5. My x is -8. And I don't know what b is yet, but I'm going to find out. 1 equals, put this over 1, -48/5 plus b. I'm going to add 48/5 to both sides. Here's where I'm going to do one little thing that may be a little less than obvious. I'm going to change 1 to 5/5. So I can add it to 48/5. Just add my numerators, 53/5. So I now have the y-intercept, I have the slope, I've got the equation of my new line. Y equals slope times x plus b. So that's what they're looking for. Y equals all right, consider the following relation. Notice it's these points define these particular points. These points on the grid represent these ordered pairs. Notice the following relation. Question: determine the domain and range for the relation. Here's where I remember. The domain, when I have a bunch of ordered pairs, is the set of x coordinates, or you might say first elements. So it's just all the first elements. 4, 4, 2, 3. I don't need to repeat 4, so it's 4, 2, and 3. That's the domain. And likewise, similarly, the range is just a set of all second elements. And I'm looking at -3, -4, -3. -3 is repeated, only put it once. -3, -4, -2. And order doesn't matter, so don't worry about that. So this is my range. So that's what they're looking for here. Find the domain and the range. Got it. I got a step 2. Determine if the thing is a function or not. All right. Here's where we're going to look to the vertical line test, remember, to see if this graph is a function. And I know graphs typically have, infinite number of points, but this has 4 points. It's still a graph. Does it pass the vertical line test? No, look here. It fails the vertical line test. Since it fails the vertical line test, I need to be able to give 2 points that demonstrate that it fails the vertical line test. They are 4 something and 4 something else. Let's see what they are. 4 -3 and 4 -4. Is it a function? No. If it's not a function, give me 2 ordered pairs. All right. 4 -3, 4 -4. You may also recall that in a function, I cannot have the same first element repeated. I do here, so it's not a function. right? Consider this function. G of x equal x minus 1 in parentheses squared minus 9. Now, in simpler form, this is the quadratic function. G of x equal x squared. It's been transformed a little bit, but that's okay. And the reason it's okay is that this guy is in vertex form. Vertex form means it's doggone easy to find the vertex. I simply take the opposite of this number, that's my x, and exactly this number. So my vertex is the opposite of that, which is positive 1, and exactly that, which is negative 9. Hey, that was easy. Now look, this is an x, this is squared. This is going to be an upward turning parabola. Why? Because if I flesh this out, I would get a positive x squared. So I know it is an upward turning parabola, and it has, by the way, it has a vertex at 1, negative 9. Let me just go ahead and put that in there. So it's a parabola that's going to look something like this, and it's going to cut the x-axis, isn't it? So let's find the x-intercepts. How do I find x-intercepts? I let y equals 0 and solve. I don't see a y. Oh yeah, I can always say g of x is the same as y. So I'm going to let y equal to 0 and solve. So here we go. Okay, your problem is going to look just like this. Do it this way. Get the term with the x squareds by itself. So I'm going to add 9 to both sides. I'm going to turn this around the other way, make it x minus 1 squared equals 9, if you don't mind. Well, how am I going to get this unsquared? That's right, I'm going to take the square root of both sides. When I take the square root of something squared, it's just the something. Now here's where you need to remember. I need to get two answers, so I take both the positive and negative square root of 9, plus or minus 3. So my intercepts are going to be x minus 1 equals plus or minus 3. That doesn't tell me what they are yet, does it? I need to solve this guy for x. Now watch this. This is a potential error. It's made all the time. X minus 1 equal plus or minus 3. Many people do this. Hey, I'm going to add 1 to both sides, and I get x is plus or minus 4. No, no, no. I have to think of this as two. Bottom line is I cannot add to a plus or minus. I have to add to them individually. So I have to think of this as x minus 1 equals 3, or x minus 1 equals negative 3. Now I'm ready to add 1 to both sides. X is 4. There's my first x-intercept. X is negative 2. There's my second x-intercept. So my two intercepts are at 4 and at negative 2. Find the x-intercepts. They are 4, 0 and negative 2, 0. Express them as ordered pairs. I did. Find the 2 points. When I find these 2 points, the Hawks software will automatically graph your parabola for you. So with these points, it's going to look something like that. Something like that. All right. Consider the following function. g of x equals 3/4 absolute value of x. First thing to do, identify the general shape of the graph. General shape of the graph is going to be one of these four guys. Now here's where I highly suggest you have handy this sheet. It has the 9 basic functions that we've gone over. I'm going to have this attached to your review, so you'll have this to run off, but have this handy. Looking for the absolute value. There it is. It's an upward turning v. So I am looking for an upward turning v. Got it. That's what I picked. Now find 2 points on the graph of this function other than the origin, other than 0, 0, that fit within the graph of 10, -10. Express each coordinate as an integer or simplified fraction. Now once again, my function is g of x equals 3/4 absolute value of x. Now you can do anything you want, but let me just make a suggestion. Remember, this is the same as y equals, right? This is my y. So as I pick x's, I would think it would be wise to pick an x that when I take 3/4 of it, it would turn out to be a whole number. That way I could easily represent it as ordered pairs. So I'm going to pick 4, and I'm going to pick -4. By the way, if you thought of using 0, it says other than the origin. You can't use 0, 0. So I'm going to use 4. So here we go. Y equals 3/4 absolute value of 4. Y equals 3/4 of, what is the absolute value of 4? Why, that's 4. 3/4 of 4 is 3. All right, let's do -4. Y equals 3/4 of the absolute value of -4. What is the absolute value of -4? Why, it's still 4. I'm going to get the same answer, 3. So I put these points in, find 2 points. I think I have to plot them since it doesn't give me a blank to put it in. So plot them 1, 2, 3, 4, 1, 2, 3. And 1, 2, 3, 4, 1, 2, 3. And Hawks will do the rest for you. All right, let's consider the following functions. Notice how simplified this expression is. F of -2 is 1. G of -2 is -4. That's all they tell me about the functions, just basically 2 ordered pairs. Well, they're going to ask us to find the sum, difference, product, and quotient of these 2 functions. So remember, let me write this down again. F of -2 is 1. G of -2 is -4. All right, it says find f plus g, the sum function, f plus g of -2. All I have to remember is that just means f of -2 plus g of -2. That's all it is. Whatever f of -2 is, 1, plus whatever g of -2 is, that would be -4. I get -3. It's that simple. Find f minus g of -2. That just means f of -2 minus g of -2. That just means 1 minus a -4. It's 1 plus 4. That's 5. F times g of -2. That just means f of -2 times g of -2. Just the basic definitions of these operations on functions. So f of -2 is 1. g of negative 2 is negative 4. 1 times negative 4, negative 4. And finally, the quotient of the 2, that just means f of negative 2 over g of negative 2. F of negative 2 over g of negative 2, it's negative 1/4. Not bad at all, huh? All right, here's the fifth combination of functions that's a little bit unusual, the composition of functions. It says find f of g of 1 for the following functions. F of x is defined to be 3 plus the square root of x. G of x is defined to be the square root of x plus 15. It says find f of g of 1 for the following functions. Round your answer to 2 decimal places if necessary. That means I'm going to need to have my handy dandy scientific calculator on the ready. All right, first definition, f of g of 1. What does that mean? That means the first function evaluated at the second function. F of g of 1 means f, whatever that is, defined at g of 1, whatever that is. So just like order of operations, I work from the inside out. I need to find g of 1 first. G of 1 is going to be, everywhere there's an x, I'm putting a 1. G of 1 is defined to be 4. So this means f of 4. Why? Because g of 1 is 4. Now I have to evaluate the function f at 4. So f of 4 means 3 plus the square root of 4. That means 3 plus 2. That means 5. Hey, didn't need my calculator for that after all, did I? This is number 12. F of g of 1 is 5. This is the key part to remember. This is what's going to allow you to work the problem. F of g of 7 means f of g of 7. Got to find g of 7 first, then evaluate whatever you find at f. All right. Consider the following polynomial. All right, I'm considering it. Express it in descending order. You know what that means. Largest exponent to smallest. So it's going to be 7x to the 14th. What's next? Minus x to the 6th. What's next? Plus 2x squared. What's next? Plus 1. Identify the degree. What's the degree? Oh yeah, the largest exponent. That would obviously be 14. Don't put 7x to the 14th, just put 14. And identify the leading coefficient. That means the coefficient of the leading term. My leading term is 7x to the 14th. The coefficient of that is just the 7. No problem there? All right, factor the following trinomial if you can. If you can't, say not factorable. Now notice I have a 1 in front of my x squared. That means I'm looking for the two numbers. The two numbers that multiply to give negative 12 and add to give the coefficient of x. I don't see a coefficient. Oh, that must be a 1. So I'm looking for two numbers that multiply to give negative 12, add to give a positive 1. Start with your multiplication. What multiplies to give a negative 12? 1, negative 12, negative 1, 12, then add to 1. 2, negative 6, negative 2, 6, doesn't add to 1. 3, negative 4, negative 3, 4. Hey, that adds to 1, doesn't it? So here are my two numbers that multiply to give negative 12, add to give a positive 1. and I break my trinomial into the product of two binomials, it's -3 and +4. Watch your signs. All right, -3 +4. All right, completely factor the given polynomial if possible. You know what you got to do first? Recognize what this is. You're going to have an example of this. It's called the difference of squares. And it always factors. Difference of squares will always factor. It'll always factor into two binomials. You take the square root of this guy. That goes here and here. Square root of 25 is 5. Square root of this guy goes here and here. That's going to be 3x and 3x. And always a plus and a minus. Always one sign of each. So square root of this guy, here and here, square root of this guy, here and here, plus and minus. And by the way, don't switch it to make it 3x plus 5 and 3x minus 5. That's not the same. Believe me, it's not the same. Do it in the order you're given here. So my order I'm given here is 5 minus 3x and 5 plus 3x. Okay, and it doesn't matter which order you put these guys. All right, 16. Solve the following polynomial equation by factoring or using the quadratic formula. All right, fingers are crossed that it factors. So let's see if it does factor. Because if it factors, it's going to be easy. Quadratic formula, a little bit more challenging. A little bit more places to stumble, so to speak. All right, what are we looking for? We're looking for two numbers that multiply to give 37 and add to give -5. Hey, the only things that multiply to give 37 are 1 and 37 and -1 and -37. And this is the only one that's negative. Certainly doesn't add up to -5. So, sorry gang, factoring is out. That means quadratic formula. And you know it, x is the opposite of b plus or minus square root of b squared minus 4ac, everything over 2a. Which means I have to first of all recognize a, b, and c, and note them. A is the coefficient of x squared, b is the coefficient of my x, c is my constant number. Good there? So let's fill it in. X is the opposite of b, the opposite of -5 is 5, plus or minus the square root of b squared. I'll go ahead and write the whole thing out. B squared minus 4 times a times c all over 2 times a. If you did some of that in your head, you're good to go. Don't worry about it. 5 plus or minus. Keep in mind, b squared will always be positive. Why? Because it's squared. Whatever's squared is going to be positive. -5 squared, 25. I only got one negative in here, so whatever I get when I multiply 4 times 37, it's going to be negative. So 4 times 7, 28, carry 2, 12 and 2 is 148. Uh-oh, see what you're going to get, right? You're going to be getting a negative under the radical. 5 plus or minus the square root of, that's 123, negative. It's as easy as 1, 2, 3. Okay. All right, they're not going to accept it like this. you have to simplify or have to indicate that you know what happens when you have the square root of a negative. That's the I concept, right? So it's 5 plus or minus I times the square root of 1, 2, 3. Now that's your answer, but I have a feeling they're going to ask you to put it in a comma, this comma, that solution. So you're going to have to break this down. So it's going to be 5, oops, it's going to be 5 plus I square root of 1, 2, 3 over 2, comma, 5 minus I square root of 1, 2, 3 over 2. All right. Number 17, identify the correct graph of this guy. Hey, check it out. X squared, get yourself a parabola. So, and by the way, x squared is positive, right? So it's going to be an upward turning parabola. It's not going to be that guy. It's not going to be that guy. It's going to be one of these two. I just don't know yet where it's going to cut the x-axis, so I'm going to have to find out. I'm going to have to find my x-intercepts. So here we go, minus 2x minus 8. Let's find the x-intercepts. Now you know how to find an x-intercept, don't you? Doesn't matter where. Anytime you want to find an x-intercept, you let y equal to 0 and solve for x. Remember, this is my y. So I want to set it to 0. So this is basically solving a polynomial equation, in this case a quadratic equation. Steps, set to 0. Done. Step 2, factor. All right. So I'm looking for two numbers that multiply to give negative 8 and add to give negative 2. All right, to get negative 8. 1, negative 8, negative 1, 8, 2, negative 4, negative 2, 4. That's it. Do any of these pairs add to negative 2? Yeah, that one right there. So there's my two numbers. So now I'm going to factor it. X plus 2, x minus 4. Now step 3. Set each factor equal to 0 and solve. Well, that's going to be easy. X plus 2 equals 0. That means x is negative 2. X minus 4 equals 0. X is 4. So my x-intercepts are the points negative 2, 0, and 4, 0. Let's see if that answers their question. Identify the correct graph, and we can't yet because I got to do my x-intercepts first, which are negative 2, 0, and 4, 0. Okay, so negative 2, 0. It's positive 2, 0. Hey, there's negative 2, 0 and positive 4, 0. Those are the 2 points I'm looking for. This is my graph. All right, it also says find the y-intercept. How do I find a y-intercept? Oh yeah, I let x equal to 0 and solve. So let's go back to y equals x squared minus 2x minus 8. I'm going to let my x's be 0. That's 0, that's 0. y is -8. So let's see. Yeah, look at there. It cuts the y-axis at the point 0, -8. That's reassuring, huh? So in ordered pairs, as ordered pairs, my y-intercept 0, -8. All right. It says find the restricted values for x for the following rational expression. And here it is. I'll go ahead and write it out here. Okay, find the restricted values for x. Restricted values mean values that make the denominator 0. Remember, that's restricted. Cannot have a 0 in the denominator. So what do? I set the denominator equal to 0 and solve. It's that simple. Divide by 8. X is -6/8. That simplifies -3/4. So I do have a restricted value, and it is -3/4. Answer, -3/4. All right, consider the following relation. Remember, this relation is just expressed as a series of ordered pairs. That's fine. Here's my relation. Find the inverse. Now, if you have a relation or a function expressed as ordered pairs, to find the inverse, you simply reverse each ordered pair. Take every xy, make it a yx. So my set of ordered pairs is 5, 9. Hey, just turn them backwards. 10, 8. 4, 2. And -8, -2. So there's my inverse. That was easy. All right, find the domain and range of the inverse. Remember that the domain means set of first elements. Range, set of second elements. So my domain is the set of first elements 5, 10, 4, -8. My range is the set of second elements, which is 9, 8, 2, -2. That's pretty straightforward. All right, simplify the expression using the properties of exponents. All right, now I can do this in a couple of ways, but there's one way that makes it very, very simple. Anything to the 0 power is, do you remember? 1. Any real number to the 0 power, now we know there's an exception, but we're not going to worry about it. Anything to the 0 power is 1. So look here. Anything to the 0 power is 1. So that just means -3 times 1. Oh my goodness, I'm finished. Now I could have gone through the steps of multiplying this exponent by all the exponents on the inside. I'd have gotten the same thing. But keep in mind that anything to the 0 power is 1. All right, simplify the following. That's 64 to the 1/2 power. Here's where I need to remember what a rational exponent means. It means a radical expression. So this little number goes right there. It's the index. The base goes right here. And the exponent goes right there. So basically this means if I drop all the extraneous stuff, this just means the square root of 64, or 8. Remember, if there's no index visible, it means a square root. If there's no exponent visible, it means 1. So my answer, 8. Just keep in mind, square root, 1/2 power means square root. 1/3 power means the cube root. Keep that in mind. All right, use elementary properties of logarithms to solve the following equation. We've done this pretty recently, so this shouldn't be too surprising. Remember, I can always express a logarithmic expression in exponential form. I don't know about you, but that's not too clear. However, when I put it in exponential form, it means that to that power. That's my base. That's my base in my expression as well. 3 to the 3rd power equals 7x. Oh my goodness, this is going to simplify nicely. 3 to the 3rd power, 9 equals 7x. Divide both sides by 7, and I'm finished. X is 9/7. So the key to this problem is going to be express it in exponential form. When you do, you're going to get something very reasonable to work with. All right, use the method of substitution to solve the following systems of equations. If I use the method of substitution, what that means is solve one equation for x or for y. And then substitute in the other equation. I'm running out of room, so let me use this. Negative 2y equals negative 16. And negative x plus 4y. This is number 23. All right, solve one of these guys for x or for y. If I was doing that, I might think of solving this guy for x. It's all by itself. But hey, wouldn't it be easy to solve this guy for y? All I have to do is divide both sides by negative 2. And I've already got y. Y is 8. Remember, when we're solving this system of linear equations, we're finding where these two lines intersect. They intersect at an x, y. I've already got the y. It's 8. All I have to do now is substitute this value back in the other equation. So negative x plus 4 times 8. $32. Yep. Minus 32. All right. So negative x plus 32 equals 21. Subtract 32. I get negative x is 11. Negative. Negative x is negative 11. Multiply both sides, divide both sides by negative 1. I get x is 11. So my point is 11/8. Is that how they asked me to express it? Answer 11/8. All right. Same concept. Use the method of substitution to solve the following system of linear equations. It came out on the next page, so it looks like that. It's number 24. X plus 4y is 16. 7x, 8y, 12. Now here's where you got to be smart. Which one of those equations are you going to solve for x or for y? If you pick the second equation, you're asking for trouble. You're going to get fractions. If I pick this first equation, all I have to do is move the 4y to the other side and change its sign, and I've got it. So let's use the first equation. There's already a 1x all by itself, so that's going to be very nice. Minus 4y. So I get x is 16 minus 4y. So I have solved one of the equations for either x or y. Then in the other equation, I'm going to substitute what x is. That's what x is. Instead of 7 times x, I'm going to multiply 7 times what x is, 16 minus 4y, plus 8y. Notice what I got here, an equation with just y's in it. That means I can solve this guy. Very nicely. It's just got y's. See, 6 times 7 is 42, carry 4, 1 times 7 is 112, 4 times 7 is 28. Y's are on this side, right? Get them together, negative 20y. Subtract 112. Negative 20y is, that's going to be negative 100. Divide both sides by negative 20. Y is 5. Okay, remember, I need an ordered pair. Where these two lines cross, they cross at the point something 5. So I got this much. Now I need to go back to this expression. Minus 4 times y, but y is 5. Substitute what I know y is right here, and then I got x. Here's my point. Negative 4, 5. Answer, negative 4, 5. All right, Gina decided to leave a 15% tip. Oh, good for you, Gina. After eating dinner at Sun Bistro. The bill was that. What's the total amount she would pay for the bill and tip, round to the nearest cent? So I'm going to use my calculator. I'm not going to try to do this in my head or on paper. And I'm going to remember that 15% is the same as multiplying by 0.15. So I'm going to multiply 31.15 times 0.15. And what I get is $4.6725. That's the tip. The total is $31.15. So I'm going to add 31.15 to that. And what I get is a total expenditure of $35.8225. But it says round to the nearest cent. That means cent is hundredth. So that's the place I round to. So I go to the third decimal place. See if it's 5 or bigger. It's not. So don't worry about it. 35.82. All right, some properties of exponents. This is the first property of exponents. It says, when I have the same base in multiplication, what do I do with my exponents? I add them up. Now you would do this in your head probably, but I'm going to show what I'm doing here. That's x squared. All right, this is the third property of exponents. It says when I have the same base in a ratio or a fraction situation, what do I do with the exponents? I subtract them. I always subtract the smaller from the larger wherever the larger happens to be. Expand any numerical portion, so 8 squared is 64. All right, simplify this expression. This is x to the negative 5. Question, why is it not simplified? Oh yeah, it's got a negative exponent. Negative exponents are never in a simplified form. So I have to think of this as a fraction and remember this principle. Move a factor to the other part of the fraction and change the sign of the exponent. That's it. Only positive exponents. Got it. So 1 over x to the 5th. Just simply not leaving an exponent negative. All right, solve the following elementary exponential equation. Now here's what we're going to do. I don't know if you remember doing this. We're going to, how do I put this? Express both sides with the same base. Okay, right now the base here is 10, the base here is 1,000, so they don't have the same base. Here's what I'm going to do. I'm going to substitute 10 to the third, because I want the same base, 10 to the third for 1,000. 1,000, 1, 2, 3 zeros is 10 to the 3rd power. So in the place of 1,000, I'm going to put 10 to the third. Don't forget it's 1,000 to the negative x equals 10 to the 2x minus 12. That gives me 10 to the 3 times negative x, negative 3x, equals 10 to the 2x minus 12. This is exactly the situation I want it to be in. Same base. Why? Because if the bases are identical, that means the exponents are equivalent. Negative 3x is the same as 2x minus 12. So let me write this where? Negative 3x equals 2x minus 12. I'm going to subtract 2x from both sides. Get negative 5x equals negative 12. Divide by negative 5, x is 12/5. Sorry for the cramped space there. X is 12/5. All right, is this it? I think this is it. Ready? Use the elementary properties of logarithms to solve the following equation. This is going to be exactly like this guy when we express it in exponential form. It's going to be that to that power equals that. Hey, that's going to be easy. 2 to the 3rd power is 8. Divide both sides by 7, and I got it. But the key is express in exponential form. All right, that is what you need to study for the final exam. Once again, these problems are first cousins to your final exam problems. If you can work these, you can work the problems on the final exam. I will be including in what I put on Quickly Content, the list or the common functions sheet. So you'll have that handy. I'll make sure you have this guy visible so you can run it off and have it handy. So you're going to need to have your calculator, printed out content of your final exam review and your sheets here handy. All right, and you have, again, 2.5 hours, anytime from Friday 8 in the morning to Sunday at midnight, July 3rd through the 5th. Good luck.